this question is about magnetic fields, but also about the nature of forces, work done, and whether or not forces acting perpendicularly on a particle actually do any work. So we're given this situation, which looks fairly unusual or fairly interesting or complex. So different magnetic fields are present in two chambers. Particle that enters the first chamber at a velocity of 80 meters per second, deflected into a circular path of a radius 200 millimeters. In the second chamber, it follows a circular path of radius 100 millimeters. Now, at that point, there's lots of stuff you could work out. There's lots of stuff you could get. Oh yes, I remember this, and I can start doing calculations. I can use F equals BQV. I can see that it's entering perpendicular to a magnetic field, so I can work out that. I can use the radius and the formula for the force. The centripetal force is mv squared over r to work out all sorts of things. But I need to just be a little bit more considered and read what the question's asking me to do. So it says the particle leaves the second chamber at a speed of, and then we're given some options. So then I'm looking at this to think, well, why would it change speed? Now, it certainly changes velocity. If I look in the first chamber, it enters the first chamber, moving perpendicular to the magnetic field. There is a force. The force acts perpendicular to the velocity. So that force does no work because it is always acting at 90 degrees. So no work is done. It never moves. The velocity of the particle never results in it moving in the same direction as the force is acting. So no work is done. If no work is done, then no kinetic energy is gained. So this particle leaves the first chamber as the first kinetic energy, the same kinetic energy that entered it, so same velocity. So it enters the first chamber at 90 degrees, it exits the first chamber at 90 degrees, and then it enters the second chamber, and again, the magnetic field is acting in such a way in the second chamber, it's in the opposite direction, and that'll be quite hard to engineer, I'm sure, but it's still acting at 90 degrees. So again, it changes the direction, but there's no change in the speed. So there is a change to velocity, but there's no, the particle at no point moves in the direction that the force is acting. It's always at 90 degrees to the direction the force is acting. So no work is done. Again, no work being done means kinetic energy stays the same, so the speed remains constant throughout. So velocities are changing, but speeds remain constant. So the answer must be 80 meters per second.